Hello my dear students, welcome to your online class again, and today we will be continuing the chapter Laws of Motion from your physics textbook, and this is going to be the last topic of your chapter. So what we were left with was the Newton's third law of motion. So the Newton's third law of motion, very simple, so which states that to every action there is equal and opposite reaction. So there are two important words, action and a reaction. For example, we have here a table. If a book is laying on the top of a table, there are two forces acting on it. The first one being the weight which acts vertically downward is the action. Even though the weight of the book acts downward, but the book, it does not penetrate the tabletop and falls down on the ground. Why? It's because the book is also applying the equal and opposite force to that of the weight which is acting towards the center of the earth, which is known as the reaction force. So hence, when a book is kept on top of a table, there are two forces acting on a book. The first being the action force, which is the weight of the body, and the second one is the reaction force, which the tabletop applies on a book. There are many such examples of the Newton's third law of motion. For example, pushing a wall. When you push a wall, the wall pushes you back with the same force. And the motion of the rocket. In a rocket, the liquid hydrogen, it burns and then it provides the sufficient thrust to lift the rocket up in the space. So after this Newton's third law of motion, we have another important topic which is known as the law of gravitation. So what does the law of gravitation tells us is whether the two bodies is of the size of the planets or maybe subatomic particles, irrespective of their charges, they always attract one another. So suppose if we have two objects or two bodies, like I have two objects A and a B separated by a distance r, and the mass being m1 and m2. Then the law of gravitation, it states that the body A will attract the body B by the force directly proportional to the product of their masses and inversely proportional to the square of the distance separating them. So which is the universal law of gravitation. So the universal law of gravitation states that the two bodies of the masses m1 and m2 attracts one another with the force directly proportional to the product of their masses and inversely proportional to the square of the distance separating them. So when we combine these two, I get f m1 m2 divided by r square. Now to remove this proportionality sign, I insert one constant, f is equals to g m1 m2 divided by r square. And this g is known as the universal gravitational constant, and its value is g is equals to 6.67 into 10 to the power minus 19 Newton meter square per kg square. So thus this is the mathematical expression of the universal law of gravitation, which states that the force of attraction is directly proportional to the masses and inversely proportional to the square of the distance separating those two objects. So the another is the acceleration due to gravity. So if one of the body here is the earth, then the attraction, or we can say that the earth attracts all the objects towards its center. So whenever a body freely falls under the gravity, so the force with which the earth pulls the object is approximately equal to 9.8 Newton. So in this formula of force of attraction between the two masses, I replace one of the mass by the mass of the earth and r with the radius of the earth. So substituting the value, we get the force of attraction or the acceleration due to gravity is equals to 9.8 Newtons. Then comes the mass and the weight. So what is mass? The mass is the amount of matter contained in a body, which you have been studying from your junior classes. And what is weight? weight is the force with which the earth attracts the body towards its center. Apart from that, the mass is measured in terms of kilogram, but whereas the weight can be measured in terms of Newton or dyne. Now the last and the most important topic of this chapter is the relationship between the universal law of gravitation, that is capital G, and the acceleration due to gravity, small g. So to start with, what we have learned in the Newton's second law of motion, the force is given as the product of mass into acceleration. Now if a body is falling freely under the gravity, so this A can be replaced with G, which is the acceleration produced due to the Earth's attraction. So thus we can write F is equals to m into G, since, so I write this as equation 1. Also from the universal law of gravitation, I also have the formula F is equals to G m, where m is the mass of the earth and small m divided by r square. So this is equation number 2. So since the left hand side, it consists the same expression, that is the force. So I can easily equate the right hand side of the equation. Thus I have, so therefore I get m into G is equals to G m divided by r square. So I can cancel m and m. So therefore I can write G equals to G capital M divided by r square, which gives the relationship between the acceleration due to gravity G and the universal gravitational constant capital G. So this comes to the end of your chapter, the laws of gravitation. Dear students, go through your book properly, and then if you have any queries, you can please contact me in my WhatsApp number. Thank you.